lesson today is about step up and step down transformers. The big question arises here. Can we produce fire using direct electricity? This happens inside our physics lab. Let's begin this experiment to show you what is the applications of the step-up transformer. First of all, we have here the parts of the step-up transformer. We have here a 500 turns coil, and this is the primary coil. We call it the primary. And we have here 23. And we have here 23,000 turns coil. This is called the secondary coil. We have here the core. This is the iron core. We'll put these coils on. Okay, now we have the closing bridge, and this is also we continue the core inside these coils. Now let's begin. The secondary coil and the primary coil, and we close this. They are well separated and insulated. Okay, now we close this. What will happen? This is the primary coil, this is the secondary coil. The primary coil is connected to the mains, okay, 230 volts, and we have here the secondary coil, which contains 23,000 coils. Okay, I use these electrodes. This is metal electrodes to evolve out of this coil. Now, when we turn on the electricity inside this primary coil, something happens that the continuously changed electromagnet happens in this core will transfer the magnetism to this secondary coil. What happens next? Let's see what will happen when we use this primary and secondary coil. Okay? We let the two electrodes approach each other. As you can see, we have here a new kind of fire. If you do not believe that it is fire, we can use this wooden piece to show you that it's a fire. It is a fire. We can use this fire. We produce this fire directly from what? From electricity, using this step-up transformer. Now, what happens is, what we can use this fire for? What is the uses of this fire? In our home, we use this fire inside the burner of the central heating system in our home. When you turn on the central heating, you are very simply starting a step up transformer, and this happens inside the burner, and the burner now will produce fire because it contains also fuel, and this happens inside our central heating system. In our car, there's so many applications for this step up transformer. In our car, this process happens about 700 times per minute inside our motor. This happens in very quickly and rapidly and continuously in our motor, and the step up, we call it in our cars, you have a coil. If you talk about the coil in our car, this is the main appliance that produces fire inside our motor. Everyone saw inside a thunderstorm what happens. The lightning happens inside the thunderstorm. It is because of this step up transformer, but there is no electricity before. In the thunderstorm, this happens something the same. Now, let's move to the can you see what happens? This spark, you have seen, this spark happens because that the air now is ionized, and when the air is ionized, it will become a good conductor, and it conducts electricity, and what happens here, it is a kind of current, but this current moves from this side to this side. When the air is ionized, it will transfer charges from this side to other side or vice versa, and this causes a current coming through the air. This current, we call it lightning in the thunderstorm, and it happens because the ionization of air. When at what conditions the air is ionized? Let's move to the calculations. How can we ionize the air? To become the air is ionized, so it contains ions, positive and negative ions. We have to raise the voltage to 10,000 volts. This happens inside the step up transformer. We have here, we raise the voltage 46 times. When we divide the number of turns to 23,000 divided by 500,000, it is called the primary, and this is the secondary coil. Okay, when we divide the turns, we have here 46 times. The voltage is lifted and rising by 46 times. It is raised. When we divide this number of turns by this number, it is 46 times. So the voltage is increased by 46 times. So if we have 230 volts times 46 times, it is now 10,580 volts. So the air is ionized. When air is ionized, now it becomes a good conductor, and we can see the spark and what causes the fire in the air. This happens in the lab and sometimes in the nature, and there is so many uses for this step up transformer. Now let's move to the step down transformer. I hope you enjoyed this step up transformer. Now let's move to the step down transformer. What about the step down transformer? Also, we can use it for the production of fire inside the lab, and so it has so many applications in our daily life. It consists of this primary coil with 500 turns. 500 turns is connected to the mains. Okay, we have here the secondary coils with only 5 turns. So it is a step down because the primary turns is more than the secondary turns, the secondary coil turns. So it is a step down transformer. Before we use the step up from 500 to 23,000. Now it is step down from 500 to 5. What will happen when we use this step down transformer? First of all, let's explain this by calculations. The voltage now, the voltage now will be decreased by 46, not 46 times now. It is that we have here 500 to 5. The voltage will be decreased by 500 divided by 5 equal what? Equal 100 times. So the voltage is now 230 will become 230 volts will become 2.3 volts. This is a step down transformer. What happens to the current now? The current will be increased by this amount. If we have in the primary coil here 12 amps, it will become what? 100 times. It will become 1,200 amps with a voltage of 2.3. This happens inside the secondary coil. So we have here 1,200 amps and only 2.3 volts. This is small voltage, but it has so many applications. First of all, let's see what will happen. What is the use of this high current and low voltage? Turning on the transformer again. The high current is going inside these turns, but now I make this current to become clear. When I touch these two poles, I've seen a spark. But what about this spark? It is a small spark, it seems. But when we put this nail to make the current comes through this nail, I put this nail and make the current go through this nail to see what happens. To see what happens in this nail. Now turning on the primary coil. Now, it's too hot now. And when I try to apply a force, small force, now the nail is melted. The nail is melted and the current stops now. And I can fuse this nail again, okay, by touching the two sides of the nail again. Now I'll fuse. I am welding now this nail. I am welding. Now I welded this nail again and becomes a one piece. Okay, let's can use, if you want to see this nail again, it's too hot. What do you expect the temperature when I fused this nail? Again, when I melted and fused this nail, the temperature, it has been increased to 1500 degrees. It has been increased to 1500 degrees Celsius. This is the nail again. It is one piece again, and it is, I've melted this nail and now I have welded again and it became one piece. This is one of the uses of this step down transformer. We use it inside. We use it inside the welding machine, and also we have sometimes it is the main use of this transformer in the welding machine. If we now use another kind of step down transformer, by making the 5 turns, we reduce it to 1 turn. 1 turn only. Let's remove the 5 turns, and we now enjoy what will happen to the current. The voltage will be decreased and the current will be increased more and more. The current will be increased more and more. What the current will become from now? Before we begin our experiment, let's move to the what happens to the current. The current is increased from 12 volt, 12 amps to what? We have 500 turns here and 1 turn. It is increased 500 times. So it will become 12 times 500. It is about what? 6,000 amps. Now we enjoy using this 6,000 amps. Okay? Also, what happens to the voltage? The voltage is decreased from 230 to 230 divided by 500 times. So it will become about 230 divided by 500. It is now 0.46 volts. Okay. The process here happens inside some this idea for melting metals is used inside the laboratories for melting metals like gold, like silver. It is used it is mainly used by goldsmith workers and silversmith, and it is used inside. It is well used inside the what we call it metal melting induction furnaces. Okay. Let's begin our experiment. Now 6,000 amps. I will use it here inside this metal ring. It is made of. It is made from copper. Now 1, 2, 3. For this, I put a ring made of metal like tin, so as to try to melt this ring. Also, I have this piece of match to test what happened inside. Now, does it happen? Now watch what will happen when we apply 6,000 amps to this copper ring. Okay, let's turn on the primary coil, and we have here the secondary coil. Its temperature will be increased up to more than 1000 degrees. Now, can you see the melting process? What happened to the metal ring inside? It is now fused and melted, and if we apply this piece of match to see what is the temperature of this liquid, now we can pour it. We can pour a lot of this metal. It became a hot liquid. The melted metal now, I pour it inside this bowl. Okay. This is what happened to the tin inside this ring. This ring is it is the primary coil. It consists of one coil only, one turn only, and it is used in the induction furnaces inside in some laboratories of goldsmith and silversmith. I hope you understood what is the main differences between the step up and step down transformers. The step up transformer, it rises and increases the voltage and decreases the current by the same ratio, and in the step down transformer, the voltage is decreased and the current is increased by the same ratio. So it has so many uses in our daily life and so many applications. This is and also you can use the calculations for the primary and secondary coils to calculate the voltages and the currents when we use the step up and step down transformers. Thank you.